Welcome to lesson 5.4 on percents. This year we've cut some of the content that you've done in grade 7 and 8 with simple and compound interest and some other questions with percents. So we're only going to work through 2 questions for this lesson. Question 3 says, a baseball team has won 50 games out of 75 played. So it's won 50 out of 75 played, but there still are 45 more games to play. So how many of the remaining games must it win? That's going to be our x that we're going to solve for. How many of the remaining games must it win? That's going to be our x. In order that the percentage of games won for the entire season will be 60%. So the percentage win is always we take the number of wins over the total num of games played. And in this question, we know we've already played 50 games, and then we have x more to play that it's got to win. So 50 plus x. And then we're going to look at the total number of games played. Well, we've already played 75, and then we have 45 more still to play. So by the end of the season, it's going to be 75 plus 45 games in total. And overall, we want that percentage win to be 60%. So this here is what we're going to be solving for. And instead of 60%, I'm going to cross that out and write it as a decimal. To go from percents to decimals, you divide by 100, so that's going to equal 0.6. And if we cross multiply this, I could even write it as 0.6 over 1. I would be getting 50 plus x times 1 equals, I need a different color, 0.6 up top. You know what? I'm going to erase that whole thing so that it's easier. Instead of 60%, I'm going to write it as a decimal, which would be, so the 60% is 0.6. Write it as a fraction so it makes it easier for us to cross multiply. So we'd have this. So 1 times 50 plus x is just 50 plus x. That's going to equal 0.6 times 75 plus 45 equals 120. So it's going to be 0.6 times 120. So I get 50 plus x equals 0.6 times 120 gives me 72. X equals 72 minus the 50, because I took that 50 that was being added and we'll subtract it on the other side. So x equals 22. And if we look back and see, what were we asking? X was how many of the remaining games it must win. So therefore, it must win 22 of the remaining games. And yes, there are other ways to do questions like this. This is just one way that I'm showing you that will work. Question 4. In a jar, there were 200 candies. 70% of them were red. C ate some candies, and the jar now contains only 60% red candies. How many red candies did C eat? Sorry. This is going to be our x. How many red candies did C eat? That's going to be our x. And in this question, the percent red is going to equal the number of red candies divided by the total. And we know we started off with, well, let's see, we had 200 candies and 70% of them were red. So let's work that out down here. So 70% of 200 means 0.7 times 200, which means 140 of them were red at the start. So we start with 140 of them, and then we eat some of them, or C eats some of them. So we're going to subtract away all the ones that they ate. We started off with 200 candies, but then C came along and ate a certain number of them, X. And after we take away that number of red, that's going to equal 60%, but I'm going to write that as 0.6. And it's 0.6 over a ghosty 1, so that we can cross multiply. 1 times 140 minus X is 140 minus X. 0.6 times 200 minus X is going to be 120 minus 0.6X. And we're going to move some stuff around. So I'm going to bring the 140 over to that side. And I'm going to bring this minus 0.6 over to this side. So minus X was already there. Minus 0.6X. Subtracting turns into adding. So plus 0.6X equals 120 minus 140. So on the right side, we get minus 20. And on the left side, it's really like it's minus 1 plus 0.6. So it's going to be minus 0.4x equals minus 20. Divide both sides by minus 0.4. And we get that x equals 50. And when we go back to look at what x was how many red candies did C eat? So therefore, C ate 50 red candies. And that's it for the unit. Thanks for watching.